Removing the tank is also not that difficult. First off, let's remove this. We have to remove the gasoline line, and there's simply just one screw for the tank, and for that I will need a wrench, and of course I have the wrong nut. I think I need, it is a 13 1. Let's see, yep, basically just one screw. Done. And now that's a bit of a tricky part, sliding off the tank. You have to, I've done that quite a lot in the past, I think, because when I started with my moped I had lots of problem with my ignition, and I always had to look for the ignition coil, which is right under the tank. So I think in the beginning I removed this tank 4 or 5 times, so I think I can do it decently. That's what I'm saying right now, but we will see how it'll turn out. Yeah, the good thing is it is not an empty tank, it's filled, and that was of course irony because it sucks. Yeah, there we go. And that's how you remove a tank. So I'm back from vacation, and as you can see I'm already working on the next bigger project. I would say it's really awesome having 2 3D printers because those 2 things are pretty much just small enclosures, of which I have to print like 10 or 12. So having 2 printers, the Prusa Mini and the Prusa Mark III, cuts the printing time in half, which is awesome for me, who has to produce a video every week. So I have a deadline of 1 week, and that really does help me. I don't want to spoil too much. Those enclosures will be pretty important for the project, and also this solar panel is pretty important. Thankfully I received it in time. I already soldered solar tap wire to it. Question for you, is it a problem if the middle line does not have one? I wanted to save a bit on wire and thought, okay, 2 lines should be more than enough, because I will probably not be using this for high power applications. So this is just some, I would say, low current stuff. So I think the 2 tap wires on the front side and 2 on the back side should be enough. But if you have better knowledge, then let me know. Otherwise I will use it like this to, like I said, save a bit of wire. And I will use a couple of those and those enclosures. Those will be the main parts of the project. Of course there will be a bit more electronics involved, a circuit which I will explain and see how it can work together with those components. And yeah, I think it will be very interesting, and I hope you're looking forward to it. And once that is done, I already got the idea for the next video and also for the next video. So pretty cool ideas. I hope you will like them. So it finally happened. I've been producing, I think, videos here on this workbench for about 3 years now. And over time, it really got a good beating. Like, there's a lot of burn marks, and just recently I did a project which involved epoxy resin, and as you can see here, that did not end well. It was rather messy, and removing this stuff when it is wet is just a nightmare. It sticks to everything, so I said, okay, just let it sit there. I even tried removing a bit here with a spatula, but that didn't work out quite well. So I said, why not treat this workbench a bit? And that's why I got my orbital sander here, which I will use now in order to remove the coating of this workbench. And for that I also got my mask, because I think it will get dusty, but I will see in a minute. And yeah, once the top surface is gone, I will then repaint. and I hope it will look decent. I have no idea how this will turn out, but I hope it'll work. So I'm not sure if you can hear me, but this is working like a treat. I got all the epoxy resin off the workbench in less than like 10 minutes, and I think I'm about to stop as well because I got everything off that I wanted to, so I will continue with the paint, I think. So here I got the paint that I think I used back then. It was 3 years ago. It certainly looks like the right color when I look at this and compare it to this. Yes, that should work out. It's Nussbaum, which I think is walnuts, maybe in English, something like that. Works really well, I can recommend it. And yeah, let's see how that will turn out. Let me just get a screwdriver and see. Oh no, let's shake it first. How about that? It's been sitting in the shelf for 3 years. I think giving it a good shake is a good start. And the good thing at this point, it is still pretty much sealed on the top. So nothing bad will happen. I hope so. Okay, that should be enough. Let's see if I got a nice color in there. Oh, doing it with one hand is pretty hard to do. Oh boy, I know you can't see it right now, but I'm prying it open on all sides because it's so well shut tight. Oh boy. Come on. Come on. Dang it. Okay, I will do this off camera. This will take too long. I will show you when it is done being painted. So, what can I say? It looks pretty good, I think. Just like before, you can't really see the difference. Of course, the new area will be a bit darker because, like, it's a new coat of paint, so it's quite obvious. But since I do most of the filming in this area and don't look too often over there, I think that should work out just fine. And I will finish this painting and I will then continue shooting videos on it. But for now I'm done with filming. I'm working on the first project after my vacation. It is done filming, so I'm going into editing right now. And the next filming will be done maybe in 3 or 4 days. I will see. But yeah, that was me painting my workbench. If at some point you were interested in that, now you got your answer. Yeah, and here you can see that is the cable that I replaced. I mean, it doesn't look suspicious at all. It's just, I just cut it here. I didn't have a connector, so I cut it there. Just soldered on a new wire, this one, and the wire is still fine. I think the problem was at the thermistor, so I will have to remove this, and then I got the new cable here, and this one got an original connector, I think, so that should plug right in there. Then I will do the wiring in this sleeve, and then I will get to the hot end, which I think is the interesting part. So here is now the difficult part. I actually laid the printer on the side. That is what the manual recommended, and it makes sense because here we got my hot end, which doesn't look very good. It's been used quite a while. And here we can see the heater element with the red wires, I think. And down here, hope you can see it, here is the thermistor. So here it's coming in here, and we basically have to unscrew this screw here. Not sure how easy that will be because of all the PLA filament stuff around it. And once that screw is loose, we can basically push the thermistor out and then insert the new one and tighten the screw again, and then it should be held in place. But I will see in a second how easy that will be. Okay, that was way easier to do than I thought. I also removed this little plastic thing here for the airflow because it was just in the way. But other than that, I just unscrewed this little screw here, very easy to do. And now all we have to do is push on the top side here. Up. There was the old thermistor. And yeah, as you can see, the wires are missing. I guess that happens over time. And now I can just take the new thermistor right here. And hopefully it will fit. Like, that's the moment of truth. Hopefully get in there. Oh boy, I can see the problem up here. There's not enough space to get it in correctly. Let's see, maybe with a bit of force and wiggling. Come on. Do I have to remove that plastic thingy? I really don't want to. Is it metal? I will see. I will see what I can do, but I will hopefully get it to work. And as you can see, after repairing this machine for I think half an hour, we once again got the right temperature readings for the thermistor, for the hot end thermistor, and it's 3D printing once again without a problem. Yeah, I have to do some fine adjustment for the Z-axis because through this repair I think some millimeters were altered. But other than that, works just fine. I replaced a zip tie here, a zip tie there, closed everything up and put the sleeve all around the cable, and it looks like new. Of course, there's a bit dust because I've been using this machine for 2+ years, but still works perfectly fine. You can repair it very easily. I love it. Awesome. And yeah, that's how you can easily repair a Prusa 3D printer. So for this week, I got a very, very interesting subject, at least for me, who's an electrical power engineer and used to kind of work with such motors back when I was having a regular job. So this is the beginning of the video. This is a motor that was laying around on my shelf for, I don't know, 2 years maybe. It's an asynchronous motor, so it's an AC motor. And here you can see its wiring. It got 6 wires to work with, basically 3 coils, which can be arranged in a couple of different configurations. Like right now it is in the star configuration, and you have to hook this up to AC. So to 400 volts, actually, 3-phase AC voltage here in Germany has 400 volts face to face. And yeah, it will not be such a safe video, but I just wanted to show you what such an industrial motor is like, because here is where it started for me with the motor types. A BLDC motor, DC motor and stepper motor, and I say in the beginning that those are all for hobbyists. Like, you can do some really good stuff with them, but then if you move over to the professional segment to the industrial segment, then the asynchronous motor or induction motor is still the most widely used motor in the world. And the task of this video is to get this running. And to do that, I will show you how it works, how it is wired up, how the basic principle of such a motor behaves. And for that, I actually got a second one. This is also an asynchronous motor, a bit smaller. This is completely new. The reason why I got this is because this one with the gear system in the front wasn't easy to open. So I said, let's get a new one, because here it is so much easier to remove the rotor. In this case, it is a squirrel cage rotor. I will talk about that in the video. And on the inside, we can see the stator with all of its windings, and once again, the terminal box, which I will show how to wire up later. So yeah, very interesting subject, and I hope you're looking forward to it. So I guess that is the moment of truth. As you can see here, I got the new asynchronous motor and I wired it up. Oh, that one shouldn't come out. Well, it doesn't matter that much. It is wired up in the star configuration. So we got one star point on this side and then we got L1, L2, L3, which are our three phases. So it is, like I said, a three-phase asynchronous motor. And back in the day when I was more in the job field of electronics, I worked with such three-phase voltages quite often. Of course, they're pretty dangerous. If you touch them, you might have a serious problem. So for this kind of voltage, you need, as you can see, such a thick wire, which goes here to a CEE plug, socket and plug. The socket is live right now, so that is wired up to my house wiring, because here in Germany we got three-phase AC voltage, which is used for an oven or a stove. So it is no problem for me to get that. And I guess this is the moment of truth. So as I showed you, everything is wired up correctly. I checked everything, whether the ground connection truly has a connection to the metal case, which is very important for safety, and also whether all phases are separated from one another and whether the phases do not touch the ground, because then we would have a short circuit and that would of course pop the fuse. So let's see, let's connect the plug to the socket. With one hand it is of course a bit more complicated. Come on. Right. Okay, that sounded good. So it is connected, and as you can see, our motor is spinning just fine. Yeah, everything works. You can see here the fan is spinning as well, so that works just fine, and I will continue with the video shooting.